Hello everyone. I hope all of you are practicing problems on theory of equations and other topics obviously from the book which is most authentic for ISI CMI preparation. That is Taste of Mathematics. Tomato, the simple name, we say that. In this book you will find past year's question papers which is asked in ISI examinations. CMI examinations questions are all available online mode. But for ISI, past year's question paper you will get in ISI websites, but to get it together better you have this book. So today's class I will be discussing some problems taken from the book Taste of Mathematics at the 10+2 level, this one, which is actually published by ISI only in their East-West Press. Why? Because the concepts I have explained in the previous episodes, those are mainly theory. Few problems definitely I have discussed, but you need to test your ability now by solving problems from polynomials and theory of equations from this book, Taste of Mathematics at the 10+2 levels. Right now you start from here. Later on I will suggest you to do from the problem solving strategies from that Arthur Angel book. Brilliant songs are there. You can solve some selected problems from there. I will encourage you to do so because these two books I found most useful for your ISI, CMI and Olympiad examinations, apart from the challenges and thrills of pre-college mathematics and excursional mathematics. In Olympiad sessions I have already told you about some of the books which includes those two books. But right now for ISI and CMI preparation I will tell you to do it from this book, I mean Taste of Mathematics at the 10+2 level, and from Arthur Angel books. Okay, without wasting time, let us start now. Let us start with problem number 246 given in the book. That the equation has roots alpha and beta, both of which are different from half. Then the equation whose roots are 1/2 alpha minus 1, 1/2 beta minus 1 is what? Definitely you can find some of these two roots, product of roots, and you can proceed. But I would like to show you by the method which I have explained in the previous episode, that transformation of equation. So let us start by that method. You take one of the root as y. For this equation, alpha plus beta minus b by a. I am telling you again, alpha beta c by a. Definitely you can find some of these two roots with the help of these two and their product. But I will be using transformation of equation method because this method is faster than by finding sum of the roots and product of the roots. Therefore, 2 alpha minus 1 is 1 by y. So 2 alpha is 1 by y plus 1. This is 1 plus y by y. So alpha is 1 plus y by 2y. Now alpha is a root. The method I have already explained that I am applying for this sum only. Alpha is a root of the given equation. Therefore, it must satisfy it. A alpha square B alpha plus C equal to 0. Substitute this value of alpha over there, or A into 1 plus y by 2y whole square, B into 1 plus y by 2y plus C equal to 0. This is going to be 1 plus y square plus 2y expanding and multiplying by 4y square. So 2y will be remaining, 2y will cancel, plus C into 4y square equal to 0. So this will give us y square. Where do you get y square? Y square is there. It is there to be y into y and here. So you take all y square terms together. That is A plus 2b 4c y square plus y. Y is here, 2y into a. So 2a, y is there, 2b, and this plus a equal to 0. Okay, so this is the required equation. So here we get option A is correct one, 2b plus 4c twice a plus b plus a equal to 0. Option A is correct. Okay. These are the sums taken from the same book, 247 and 248. So let me answer number 247 first. That alpha beta are the roots of equation, then sum of these two. So I have taken this simple sum just to explain the method. If you write that here alpha plus beta is minus 5, alpha into beta minus 5, and then find sum here, you can do it definitely, but it doesn't look good. So what we'll do there? By using the concept of transformation of equation, we frame the equation whose roots are 1 by alpha plus 1 and 1 by beta plus 1. Let us find the equation whose roots are 1 by alpha plus 1 and 1 by beta plus 1. We take one of them as y. Let the way we did previous one, 1 by alpha plus 1. So alpha plus 1 is 1 by y. Alpha is 1 by y minus 1. So alpha is 1 minus y, that divided by y. Since alpha is a root, same method, hope you are doing it with me. Since alpha is a root of x square 5x minus 5 equal to 0, therefore we put it there, 1 minus y by y square 5 therefore 1 minus y whole square 5y 1 minus y 5y square equal to 0. So 1 minus 2y plus y square 5y minus 5y square equal to 0. So you will be getting minus 10 plus 1, that is minus 9 y square plus 3y plus 1 0. So this equation has roots alpha dash equal to what? 1 by alpha plus 1 and beta dash equal to 1 by beta plus 1. It means this equation or this one 9y square minus 3y minus 1 equal to 0. This equation has roots in the form alpha dash and beta dash, where alpha dash beta dash given this manner. So we are required to find what? Required to find alpha dash cube plus beta dash cube. Simple. This is alpha dash plus beta dash. Even you can transform the equation once more. That method I will definitely tell you. But at this stage, if you want to find, you got 3 alpha dash beta dash, alpha dash plus beta dash. You know, from this equation, alpha dash plus beta dash equal to minus 3 minus plus 1/3 and alpha dash beta dash equal to minus 1 by 9. If we substitute here, it is 1 by 27 plus 1 by 9 into 1/3. Because alpha dash, beta dash they are given here in that form, and sorry, here 3 will be there because a cube plus b cube, a plus b whole cube minus 3ab into a plus b. So this is 1 by 27 plus 1 by 9, 4 by 27. 4 by 27 is an option over there. So option B is correct. Now at this stage, you try to understand that this equation again can be transformed to get alpha dash cube, beta dash cube easily. Okay, how? Let us form an equation. I am showing you alternative method. Let us form an equation whose roots are, let's form an equation whose roots are alpha dash cube and beta dash cube. How to? You start this way. Let, again, take another variable, t equal to alpha dash cube. Okay. So alpha dash value is what? T to the power 1/3. Now what you have to do there? You have to put alpha dash over there. Why? Because alpha dash will satisfy as alpha dash is a root of 9y square minus 3y plus 1 equal to 0. So 9 alpha dash square 3 alpha dash plus 1 equal to 0. Okay. Now put alpha dash over there, but be careful. When you are going to put alpha dash over there, the equation going to be of this form: 9 t to the power 2/3 3 t to the power 1/3 plus 1 equal to 0. What you have to do there? You have to remove cube root from there. For that you need to make its cubing. So you write 3 t to the power 2/3 minus t to the power 1/3 equal to minus 1/3, divided both sides by minus 3. No, by 3. Now cubing both sides, 3 t to the power 2/3 minus t to the power 1/3 cube equal to minus 1 by 27. Simplify it. This is going to be 27 a cube plus b cube, a cube minus b cube minus 3ab into a plus b. So a cube is what? 27 t square minus b cube, that is t, minus 3ab into a minus b, that is minus 1/3 only, minus 1 by 27. Therefore, 27t square minus t minus 27t plus 1 by 27 equal to 0. Clear? So now you have to find sum of the roots. Okay? This is going to be minus 3t. So you get 27t square minus 4t plus 1 by 27, 0. So sum of the roots. This equation has roots of the form alpha dashed equal to what? Alpha dashed cube and beta dashed cube. Alpha dashed cube, beta dashed cube means 1 by alpha plus 1 cube and 1 by beta plus 1 whole cube. So sum of the roots alpha dashed cube plus beta dashed cube is sum of the roots, that is sum of the roots, that is 4 by 27. This method is actually longer than the method I have used there. So you must see which one is convenient for you, where you are getting the answer first. You substitute there. No detailing is required. As soon as you get the answer, it's fine. Done. 1 MCQ. Now for this particular sum, number 248, you know the concept of integer root. I just wanted to remind you by taking the easiest one. Since alpha is a positive integer and roots of this equation are rational numbers, you might have noticed this, then the smallest value of alpha is what? The concept I have already explained in the episode. I don't remember. If you follow the previous episodes, you will get there the concept of integer roots. Alpha will be a divisor of 6. Okay? Since alpha divides 6, to get the rational roots, alpha must divide 6. Alpha divides 6, it implies what? Alpha must be plus minus 1, plus minus 2, plus minus 3, plus minus 6. Now go by the options. What is given over there? Smallest value of alpha. Smallest value of alpha is not 4, it is not 5, even 6 also. So none of the options given up to A, B and C not correct. It is going to be option D. This is the concept of integer root, which I have explained in some previous episodes in details. You must go through it. This problem 257, number of real roots is what? 0, 3, 5, 1. They did not ask you to find the roots. They asked you just a simple question: how many real roots are there? This sum I would like to solve with the help of Descartes' tools of science. Methods are there. You can use derivative, real root, all those things. Real root concept by Newton's formula. Just Descartes' tools of science will be enough, I think. Let us see. Fx is x to the power 5 plus 2x cube plus x square plus 2. No sign change is there. Fx signs are what? Plus, plus, plus again, plus again. So no sign change. No sign change implies, this implies no positive real root. Okay. Now find a for minus x. minus x to the power 5 minus 2x cube plus x square plus 2. How many sign changes are there for a for minus x? Minus 1. Oh, sorry. You just write the signs over there, signs of the coefficients. Minus, minus, plus, plus. Only one sign change. Only one sign change. One sign change implies one negative root, because f of minus x, one negative root only. So answer going to be D. This is very simple. Just use Descartes' rules of signs to get the answer. For 258, A, B, C be distinct real numbers. Then the number of real solutions of the equation, which is a cubic equation. Brilliant question here. But the concept we have already done. Algebraic equation or polynomial equations, those real roots of fx are separated by real roots of f dash x. Rolle's theorem, Newton's formula, Newton's theorem, all these have explained. So here, just expanding and then getting the discriminant, or do it by some higher method like Carnot's method, is not justified. Use a simple concept where you will remember that roots of fx are separated by roots, real roots of fx separated by real roots of f dash x, and real roots of f dash x separated by real roots of f double dash x continues, so on. So long you can differentiate, it will work. So for this one, to find the number of real roots for 258, we just take this one as fx. Left side fx is x minus a whole cube, x minus b whole cube, x minus c whole cube. So f dash x is what? 3x minus a whole square, 3x minus b whole square, 3x minus c whole square. Okay. Now let us find the discriminant of the equation f dash x equal to 0. So we take this one, it is going to be 3 common, then 3x square minus 2 into a plus b plus cx plus a square plus b square plus c square equal to 0. I have cancelled 3 first. So what is the discriminant here? Discriminant is going to be 4a plus b plus c whole square, 12 a square plus b square plus c square. This is nothing but 4 into a plus b plus c whole square minus, okay, this is nothing but on simplification minus 2a square minus 2b square minus 2c square plus 2 into ab plus bc plus c. Alright. So you take minus 2 outside, it is a square b square c square minus ab minus bc minus ca. You know this simple manipulation you might have done before. I am just showing you. Take 2 inside, 2ab, 2bc minus 2ca. This is going to be of the form a minus b whole square, b minus c whole square, c minus a whole square. You all know this. When you are preparing for this level of examination, this manipulation you have done. If you haven't done, do it now. Whatever. These are perfect squares, always positive, and minus 4 outside. This is less than 0 or maybe equal to 0 also. Okay? So, one thing is very clear, that this and no, not equal to 0. ABC are all real number, no condition given over there. No specific condition given over there. Distinct real numbers, sorry. I am doing 258. They are distinct real numbers, so you cannot put equal to 0 over there. They cannot be equal. Now what you observe? That f dash x is discriminant less than 0. N is a real number, but f dash x discriminant 0 means f dash x has no real root. F dash x equal to 0 has all complex roots. What about fx? It's a cubic equation. Coefficients are all real numbers. So, it can have real root, can have complex roots. But it is proved that f dash x equal to 0 has no real root. So, maximum possibility of getting fx equal to 0, only one real root. And just use your concept which you have done in complex number, simple concept, complex quadratic equation, that imaginary roots occur in pairs. If it has imaginary root, then they all must come in pairs. One of the root is alpha plus I beta, the other one going to be alpha minus I beta, isn't it? But it is confirmed that if dash x equal to 0, this equation has no real root. So, there is only one possibility of 58, it has only one real root, and that real root, that option going to be, that is A. Okay? 259. ABC are all real numbers. Then this is a fourth degree polynomial. It has 4 complex roots. Either 4 real or 4 complex. Has 2 real roots, 2 complex roots. Has 4 real roots. Finding discriminant of this equation and then solve it by biquadratic equation method is far from reality. No one does. We will be using the concept which we have done in the previous sum. Take this one as fx. AC x4 ba plus c x cube a square plus b square plus c square x square b into a plus c x plus ac. If dash x, if you find 4ac x cube 3b a plus c twice a square plus b square plus c square x plus b into a plus c. If double dash x, you can differentiate up to 3 times because 4th degree polynomial 12ac x square. The concept is explained in both polynomials and theory of equation, one of the equation. 12ac x square plus 6b into a plus cx plus 2 into a square plus b square plus c square, and then the next one f triple dash x. This is 24 acx. Now if we compare this to 0, x going to be what? 6b a plus c by 24 ac. What is the condition given over there? ABC are all real numbers. So this equation has a real root. If triple dash x has a real root. It's a polynomial equation. This real root will separate two real roots of f dash x equal to 0. So we can say that it has two real roots. Now two real roots will separate three real roots of f dash x equal to 0. So it has three real roots. These three real roots will separate four real roots of this equation. So it has four real roots. So option D is correct. Hope you have understood the method. For this sum number 272, I have already told you the difficulty of finding some of the cubes in case of quadratic by writing alpha plus beta plus gamma, that is minus 2, sigma alpha beta is 3, and alpha beta gamma equal to minus 3. You can't. It will take long time. So go by transformation of equation. Frame the equation. We find the equation whose roots are alpha by alpha plus 1, beta by beta plus 1, and gamma by gamma plus 1. So for this, let us make the substitution. Let y equal to alpha by alpha plus 1. Find alpha from here. Alpha plus 1y equal to alpha. So alpha 1 minus y equal to y. Alpha is going to be minus y by y minus 1. Okay. Now we put the value of alpha. Alpha is the root of this equation, no? So we can put it there as alpha is the root of, from the book, I think you all have this book, page 272. If you don't have, please buy it before exam. Okay, problem number 272 I am discussing. And you are also solving it with me. As alpha is the root of the given equation, therefore alpha cube 2 alpha square 3 alpha plus 3 equal to 0. Put the value of alpha there, minus y cube by y minus 1 whole cube, 2y square by y minus 1 whole square, minus 3y by y minus 1 plus 3 equal to 0. So minus y cube 2y square y minus 1, 3y y minus 1 whole square, it's alright. You have nothing to do without simplification. So it's a big one, no? You have to solve. Y cube 2y cube 2y square 3y y square minus 2y plus 1 y cube minus 2y plus 1 0. So this implies 2y cube 3y cube 5y cube minus 4y cube, just only y cube. Y square, where is it? It is 6y square minus 2y square, 4y square, and y minus 3y minus 6y, that is minus 9y, plus 3 equal to 0. Alright, 2y cube minus 3y cube minus y cube, that calculation you must have understood. Okay, so this is the equation y cube minus so the final equation, there is a mistake, it is cube, no, not square. So we should write it here. On simplification, I got this thing. Okay. What are the roots of this equation? Alpha by alpha plus 1 beta, not cube. If you want to convert into an equation whose roots are alpha by alpha plus 1 whole cube, beta by beta plus, that you can do definitely. I showed you the method. But I will be working with this alpha dashed, here roots are alpha dashed, beta dashed, gamma dashed of this form. Beta dashed equal to beta by beta plus 1 and gamma dashed equal to gamma by gamma plus 1. Alright. So, what's the sum of the roots? Alpha dashed, beta dashed, gamma dashed. That's sigma alpha dashed is 5. Sigma alpha dashed beta dashed is 6, alpha dashed beta dashed and gamma dashed is 3. You are going to find the value of alpha dashed cube, beta dashed cube, which is nothing but alpha dashed cube, it's a big one, gamma dash cube minus plus 3 alpha dashed, beta dashed, gamma dashed. Okay. Why have I written this? Because this can be simplified. It is alpha dashed, beta dashed, gamma dashed, alpha dashed square. I am factorizing this. Alpha dashed, beta dashed, gamma dashed, alpha dashed, plus 3 alpha dashed, beta dashed, gamma dashed. So this will be alpha dashed plus beta dashed plus gamma dashed, and this one alpha dashed whole square it's a long one plus just put the values we got there. This is 5, 25 minus 18 plus 9. So this is 5 into 7 plus 9, 44 I got. Hope you also have got this thing. The final answer is part B. Clear? 272 answer is this one based on the concept I have already told you. Alpha, beta, gamma are the roots of this. Then the equation whose roots are this, this and this. You start the same manner. Transformation of equation. Let y equal to 1 plus alpha by 1 minus alpha. So y into 1 minus alpha, 1 plus alpha, alpha into 1 plus y. So alpha is what? Y minus 1, y plus 1. Since alpha is a root, therefore alpha cube minus 1, 0, put it there and simplify. Y minus 1 by y plus 1 cube, y minus 1, y plus 1 minus 1 equal to 0. So this implies that y minus 1 cube, y minus 1, y plus 1 whole square. Why? Because 1 y plus 1 is there, 1 get cancelled, so it will be just this thing. No, square, because it is cube there, no? So this is minus y plus 1 whole cube 0. Just simplify it. Y cube 3y square, 3y plus 1, y minus 1 y square, 2y plus 1, y cube 3y square 3y plus 1 equal to 0. So y cube just multiply y cube plus 2y square plus y minus y square minus y cube plus 3y square plus 3y plus 1 0. Okay, so now you get minus y cube minus 6y square, that is coming minus 8y square minus 3, no, 1 plus is there, not 8. This is y square, so minus, this is going to be 7, because minus 3y square plus y square minus 4y square minus 7y square, and 3y plus y, 4y, that plus y. Okay, and this is minus 1 plus 1 plus 1 equal to 0. Clear? So this is going to be y cube 7y square minus, required equation is this, or you can write in terms of x, just replace y by x, variable doesn't matter. This is y cube 7y square, just check, y cube plus 7y square minus y minus 1, so this one, part D is the correct option. Okay, just a minute. It's okay. This one not a difficult one, that the equation has 3 roots and they are in AP, not roots in AP. Reciprocal of the roots are in AP. Then find the value. You can go by transformation. Frame the equation whose roots are 1 by alpha, 1 by beta, 1 by gamma. Then use the AP condition. You can get easily. Okay. So let us go for that. Let y equal to 1 by alpha. So alpha equal to 1 by y. Since alpha is the root of the given equation, a alpha square 6 alpha minus 1 0. So 6 by y cube, a by y square, 6 minus ay. So this equation y cube 6y square plus ay minus 6 equal to 0. This equation has roots 1 by alpha, 1 by beta, 1 by gamma. So alpha dashed we take 1 by alpha, beta dashed 1 by beta, gamma dashed 1 by gamma. They are the roots of this equation. So those roots are in AP. Alpha dashed, beta dashed, gamma dashed. This is what? 6. Alpha dashed, beta dashed, gamma dashed plus gamma dashed into alpha dashed. This is A. And product is 6. Okay, AP condition I haven't used so far. So their AP means roots alpha dashed, beta dashed and gamma dashed are in AP. Since alpha dashed, beta dashed, gamma dashed are in AP, therefore their sum, 2 beta dashed will be from 1, what do you get? You put alpha dash plus beta dash, 2 beta dash. Therefore, 6. So beta dash going to be 2. and alpha dash plus gamma dash is what? 4. Am I clear? Now use the third condition. You got beta dash. And a second condition also. From 2 what do you get? No, first from 3. If you put the value of beta dash, alpha dash into gamma dash is going to be 6 by 2, that is 3. Now from 2, you have to get this also we have to use. Alpha dash plus gamma dash we got. So you take beta dash common from first 2 plus, now put the value. This is 4 and beta dash is 2. 2 into 4 plus gamma dash alpha dash is 3. So A going to be 11. Clear? See how useful the transformation of equation is here to solve this kind of questions. Hope you have understood. A is going to be 11. So part C is the correct option. This one, the equations have exactly common root, no common root, exactly 3 or exactly 2. See, this one is a cubic equation. You can find its roots. What are those? This cubic equation, if you simplify, going to be 2x into x plus 1, 0. So x plus 1 you take common, factorize the first one, plus 2x equal to 0. So this is not a difficult one. This is a simple question. X is minus 1 and you know the roots of this equation, that is omega and omega square. Omega is minus 1 plus I root 3 by 2 omega square, here minus sign will be there. Omega square given by this. Now, does 1 satisfy this? No. If you put x equal to minus 1, not 1, minus 1. For minus 1, this is 1 minus, no, this is not equal to 0. So, minus 1 is not a common root. There is a chance of getting 2 common roots only. For x equal to omega, omega to the power 200, omega to the power 130 plus 1 going to be, this is what? Omega to the power 200. Omega to the power 200, omega cube to the power 66 into omega square, omega cube to the power 43 into omega plus 1. You are getting omega square, omega plus 1, 0. Since omega cube 1. So omega is a root. Now for x equal to omega square, what happened? For x equal to omega square, omega to the power 200 square, omega to the power 130 square plus 1. Why? Because omega to the power 200 we got omega square. So omega square and omega square plus 1. This is omega. So omega square is a root. Omega is also a root of the second equation. So exactly 2 common root. Fourth option is correct. That's all I found in Tomato book to discuss those problems with you. If you find any one, you write in comment box. I'll definitely show you. If you have any difficulty, you show it to me. Your next level will be to practice sums from Arthur Angel book. Okay? Thank you. See you again.